Good morning. Some of you know how this is going to start. There's two programmers, and they go crazy, and they commit a murder. And they get caught, convicted, and because it's in Texas, sentenced to death. Now, they're sitting in their jail cell together. And there's this tradition in Texas that you can get one last wish before you die. You know, like a meal or something. So the jailer walks into the jail where the two programmers are. He looks at them and he says, "Boys, tomorrow you die. You get one last wish. What would you like?" And the first programmer looks at the jailer and he says, "Oh, Mr. Jailer, I have always had the desire to present a thorough and academic lecture on the subject of modern product development methodology. If I could do that before I die, I'd be a happy man." The jailer looks at him and goes, "Oh, you are a sick man." "But I tell you what, tomorrow at noon, we'll round up all the prisoners, bring them to the auditorium, you can give your talk, and then we'll kill you." So then the jailer turns to the second programmer who's been in the cell listening to this conversation. "Boy, you get one last wish too. What would you like?" And the second programmer looks at the jailer and says, "Oh, Mr. Jailer, please have mercy on me. There's only one thing I need now for peace of mind. Can you arrange my execution before noon tomorrow?" So I hope this won't be quite that painful. All right. Now, a little bit about background before I get into some tips. Back in 2003, I started to become interested in the question about scaling Scrum to large multi-site and offshore development. And as chief scientist at a company called Valtech, we bought a development center in Bangalore and were interested in starting to explore how to apply it there. And so I spent time living in India and helped create Agile offshore development. At the same time, I was getting calls from companies like Siemens, Lockheed Martin, Nokia Siemens Networks about how do you apply Scrum to very large, say, 1,000-person, 5-10 site development. And so I started to do coaching and consulting and working in these product groups over the years. Around the same time, in 2003, 2004, I was invited by Xerox to serve as the lead of lean development there. We build these big digital press printers. They typically take a couple of thousand people to build one of these things, both hardware and software. And we were interested in applying lean, large-scale Scrum to the development of these. And then over the years, I've just been a coach and management consultant at places like Nokia Siemens, Alcatel-Lucent, Computer Associates, UBS, and many other companies involved in, interested in applying large-scale Scrum to, say, 500, 1,000, 1,500-person product groups. Most of my work is in the embedded space, where you're typically building hardware and software, printers, network elements, stuff like that. So this is my world. And so the context of what I'll be talking about and any questions that you might ask is in the context of kind of this space, typically 150 to 1,500 people for one product, usually 3 to 10 sites, low end 5 million lines of code, top end around 50 million, and maybe an average of the kinds of product groups I work on is maybe 800 people, 4 or 5 sites at a time. So that's my world, and the question is, how do you apply Scrum in those domains? Now, before we go any further, I don't want you to get to the impression that I actually think this is a good idea. So my books are on large multi-site offshore development, and I often say, irrespective of method, what should you do about large multi-site offshore development? Don't. It's just not a good idea. Usually the reasons why people think you need big groups for big systems is because of various wrong assumptions and thinking mistakes. because of how people are organized or that people can't learn two things and so forth. This is a quote from the first large system built in the world in software development in the late 50s and the early 60s. It ultimately involved hundreds of programmers. And I'd like to invite you to read this quote by one of the lead managers of the project. I don't know if you can read that at the back. If you had to do it all over again, how would you do it different? I would find the 10 best people and have them write the whole thing themselves. And that's really my ultimate suggestion. But nevertheless, over the years, I've been involved working around the world. I just go around the world and work in different development sites, building typically big embedded systems. And I got asked these questions so many times, I got tired of answering them. And so then I ended up writing these 2 books on large scale for multi-site, offshore development, and so forth. So that's enough about me. That's kind of the background. Now, I want to share kind of the framing of this. There's something called Galbraith's STAR model, which is an organizational design model that we use to explain how to put this together. And there's a lot of dimensions to large-scale Scrum. It impacts HR policies, to organizational structure, to interactions, to so much more. And it's a large subject, and in this short presentation, I just wanted to focus on a couple of elements that I thought would be of a special interest to this group. For example, what are some of the design implications of how 1,500 people together build systems, that kind of thing. So I want to start with, from the STAR model, focusing on things that relate to people, task, structure, and then ultimately process. So first of all, to be clear, we need to start with basic Scrum, because scaling to 100 or 200 teams still requires that basic Scrum is working. And the foundation of Scrum, the very name Scrum itself, meant a whole cross-functional team together, moving the ball down the field together rather than handing off the ball to other single specialist teams. The foundation of scaling is a cross-functional team that's doing multi-learning, no single specialist, no architects, no programmers, no testers, no business analysts. As you know, in Scrum, the only job title is team member, and cross-component, multi-learning, cross-functional teams with no single specialists. That's the atomic unit that makes large-scale Scrum work, just like normal Scrum teams, but then scaled up. And I've learned over the years that even though this is just normal Scrum 101, these kinds of teams, it turns out it's really important to stress this to make scaling work. Because it's very common in the scaling world that the organizational design is specialized around single specialists and around single component teams. So if you're a 1,000-person product group building a telecom system, it's typical that the organization will be, there's a specification group, there's a product management group, there's a system test group, there's a performance test group, there's a programming group, and even further fine-grained, there's a programming team for component 1, a programming team for component 2, and so on and so forth. So it's in these large organizations, they're typically really single specialized. And so the first key challenge in moving to these large-scale Scrum adoptions is breaking all of that single specialization and moving to a cross-functional organization. So no single function groups, no systems engineering group, no architecture team, no DBA group, no programming group, no documentation group. All of those groups need to dissolve, which has implications for existing managers and organizational structure. So we're talking about very deep change in the organization, which is why I usually end up working with C-level management, CEO, CIO, and so forth, because this is going to be a top-to-bottom organizational design change. Another implication, which I've already mentioned, is no component teams. Now, this idea you won't even know this idea if you work in small groups. In small groups, it's normal that everybody works on all the code. But in very large systems, somehow people get the idea that you guys work on component 1 and you guys work on component 2. And even though the feature spans component 1 and component 2, the mindset is that we have to have people who can only work on one component at a time, and then we have to chop up the work. Now, if you have component teams, these are small groups of programmers specialized in just a particular module layer subsystem, then what happens if you have component teams? I want to deconstruct this a little bit for you. So let's suppose we're a 700-person product group, and we've got 100 teams of programmers, and you've got, let's say, a team of 7 programmers working in one component, a team of 7 programmers working in another component, and you've got 100 different components and 100 different teams, therefore. So if you're organized like that, what happens? Well, the first question that you have to ask is, if we get a new requirement request like F1, who's going to do the requirements analysis for F1? You've got 100 programming component teams. Which one of those is going to do the requirements analysis? It's not at all clear. So if you have programming component teams, then what you put in place naturally is a separate group before the component teams called analysts or systems engineers. And they'll take these items and they'll do some type of detailed requirements analysis for them, because you don't know which of the 100 different programming teams would make sense to do the analysis. Now, the next question that comes up is, okay, we've got 100 different components, we've got all of these different teams, and we need to figure out which of the different components are going to be touched by this feature, and what are going to be the interfaces between the components. Which of the 100 component teams is going to answer that question? It's not at all clear, because we don't even know which components are involved in this feature, like telecom HSDPA, or some kind of an LTE requirement in telecom or something like that. And so if you've got 100 component teams, then the natural answer to the next question is, what components are involved? What's going to be the interfaces between the components? That's then typically given to somebody called a systems engineer or an architect, and they take these requirements that were created by some type of a specifier, and they figure out what components are going to be touched and maybe what the interfaces are between them and so forth. The next question that then comes up is, well, who's going to do the programming? And then at that point, we delegate, we chop up the work of this feature, F1, and we give little bits of it to component team 1, component team 2, and component team 3, who all make their parts of the code. But it's important to understand that the whole system isn't just waiting around for F1 to flow through the system, because there's F2, F3, F600 going on at the same time. So all of the work has been chopped up and is being done out of order. And so, for example, I remember working in Hangzhou some years ago, where this team would be working on their part of feature 1 11 months before this team would be working on their part of feature 1, just because it was convenient, because the whole organizational design is optimized around the convenience of the programmers, not optimized around the flow of highest value to the customer. So the F1 doesn't just flow through the system. There's a whole bunch going on at the same time. There's queues. There's a lot of handoff. But finally, the code is all finished. Now, which of these teams is going to do the end-to-end testing of this feature F1? Is it going to be this team or one of the other 20 teams that are involved in it? It's not at all clear. So if you've got component teams, then what you normally put in place after this is a separate group called systems testers, or a testing group, because they're the natural group to do the end-to-end testing. So I'll just ask you a rhetorical question. What does this look like? What does this life cycle look like? This is a sequential life cycle. This is a waterfall. It's critical for you to understand that if you have component teams, it engenders a sequential life cycle. Sequential life cycle comes out of component teams. And so it's very important that if we're going to move to large-scale Scrum, we have to get rid of this, because if you don't get rid of this, it will naturally derive a sequential life cycle. And it's also interesting to note how organizational structure inhibits architectural structure. This is Conway's law, or Conway's observation, that if you organize people around your software architecture, in other words, you're worshiping your architecture instead of worshiping your customer, then you will essentially start to freeze your software architecture because of the organizational politics. You get managers, they've got a bunch of programmers reporting to them. They don't want to lose power or prestige by the losing of their department. And so through politics, your architecture starts to get frozen. Now, how do you scale to, say, 1,000 or 1,500 people for large-scale Scrum? One of the ideas to apply is called requirements areas. So if you look at a product backlog in Scrum for a domain like a telecom product, we can look at all of the backlog items. And you can imagine taking all of these items, putting them all on separate pieces of paper, cutting them all up, throwing them on the floor, and then inviting your customers into the room and asking your customers to group these requirements into families that make sense from the customer's perspective. Now, the customer knows nothing about your architecture, so they're going to group the requirements into purely customer-centric views. That is what we mean by requirement areas. And for scaling, one of the things that we do is we then categorize all Scrum product backlog items into different requirement areas. Following that, we can then define what are called area backlogs. So, for example, the protocols one, the performance one, and so on. These are not separate documents. These are just views onto the one list, which is the product backlog, filtered for a particular area. Then what we can do is introduce another role in Scrum called an area product owner. In addition to the overall product owner, we'll have an area product owner for each requirements area. Then we have a set of feature teams, regular Scrum, cross-functional, cross-component, multi-learning team members of 7 plus or minus 2. And this set of teams just serve this particular area and that particular area product owner. So we've got a natural kind of decomposition. But notice that the decomposition is not based upon your architecture, which would be a very inward-looking approach and has all of the disadvantages associated with component teams. This is a decomposition oriented around your customer, around the customer perspective. So, given the idea of requirement areas and area product owners, now we come to the two large-scale Scrum frameworks, Framework 1 and Framework 2. Framework 1 is for small groups of up to only 5 or 10 teams. This is not a world that I work in. I work in a world of 100, 200 teams. But nevertheless, it's built upon this foundation of up to 5 or 10 teams. And how Framework 1 works is that you've got just a plain old product owner, and in this example, you've got 3 teams. And I'm assuming, by the way, in this talk that you all know how Scrum works. I don't have time to get into that. And in Sprint Planning Part 1, the what session, where the product owner offers the wish list to the teams in a short meeting, then we have representatives from the different teams come together. So, for example, if there's 3 teams, there might just be 2 representatives from each team that come together and meet with the product owner, and then the product owner makes the offer for the 3 teams. And normally doesn't decide which of the 3 teams are going to do what, just puts it on the table and says, here's my wish list, you guys figure out what you want. Now, if it's multi-site, because my world is usually multi-site, this will usually be happening over Skype video, and there'll be like a Google spreadsheet which presents the offer, and then through multi-site video conferencing, the people can discuss selecting from the offer. And then at the end of Sprint Planning Part 1, the team representatives go away and they do Sprint Planning Part 2 in their usual way with their normal co-located team. So from that point on, Sprint Planning Part 2 is basically business as usual. The other element that's relevant to scaling in the middle of the sprint is the product backlog refinement activity. This guideline in Scrum that between 5 and 10% of every sprint be spent on detailed requirements analysis and splitting to support future sprints. And so what happens in addition to the regular team-level product backlog refinement in the middle of each sprint is that there's a joint product backlog refinement session where, again, representatives from the different teams come together with the product owner and they do some forward analysis for future sprints that will span ultimately all of the teams. At the end of the sprint, you've got a potentially shippable product increment, PSPI. You've got continuous integration, of course, going on all the time. And you've got one sprint review for the whole product not per team. And then the product owner and then again team representatives come back together in the sprint review to see what's going on at an overall product level. As usual, the sprint ends with a sprint retrospective for each individual team, but in addition, at the beginning of the next sprint, early into the next sprint, there's also a joint retrospective where a couple of representatives from each team, like the Scrum Master and somebody else, get together and have a joint retrospective in which they ask the question, how should we improve at a system level rather than just at a team level? And this Framework 1 scales somewhere between 5 and 10 teams, depending upon the sort of context-dependent question of how many teams one person, one product owner can effectively work with. And that's very context-dependent. If you're an offshore group where the teams know little about the domain and they're taking on an outsourced product, it's typically a lower number because the teams don't know much about the domain. On the other hand, if you're a company like Xerox, where the developers have been there for years and years and the development teams themselves are real domain experts, then they can handle much more of the subject matter expertise, and then the product owner can work with more teams at the same time. So that's Framework 1. Now, Framework 2 scales up to several hundred teams. We've seen it applied to well over 1,000 people. And it's simply a set of Framework 1s for each requirement area. So if you remember the requirement areas like protocols and performance, you've got an area product owner, for example, for the protocols requirements area, and she's executing a Framework 1, so too with that area product owner. And before the beginning of Sprint Planning Part 1 for each area, the overall product owner and the area product owners get together in a synchronization meeting and discuss their local views on how they're planning to prioritize the backlog. And then the overall product owner might rebalance the choices for an overall perspective for the whole product. Okay, so that's a key sort of organizational design element. Now I want to flip subjects and talk a little bit about design. How do you scale design to a lot of teams working together in Scrum? The first thing to understand is the idea of communities of practice. So when we have single-function teams, a group of technical writers, a group of business analysts, a group of UI people, then the question of consistency related to that discipline is dealt with by the single-function team being together. All the testers are together, and then they can talk about common ways of testing. All the UI designers are together, and they can talk about common look and feel. But when we've got cross-functional, cross-discipline, cross-component teams, now all the disciplines are spread across the Scrum teams, but we still have this problem of consistency across discipline. This is a well-trodden territory, and the normal answer to it is called communities of practice. And so the idea is that for each discipline under concern, we create a separate community of practice, essentially a special interest group, but with formal organizational support. You might have a community of practice facilitator, and there will be special events related to that community, like a design conference or a Scrum Master conference or a UI look and feel conference. And the COP facilitator will normally be supported by the organization as an official role. So there will be a UI COP facilitator, a design and architecture COP facilitator, and so forth. These people are not managers, and they're not people outside of regular Scrum teams. They're just regular Scrum team members doing hands-on work. But in addition to doing hands-on work, they leave a certain amount of slack in their schedule, like 50% of the time, to cultivate this particular community. So with respect, for example, to design, you'll have a design and architecture community of practice. You'll have a design and architecture COP facilitator. And then when questions related to design and architecture come up, say like having a joint design workshop or bringing in a person to do a course or to talk about common architectural patterns, then that facilitator will ultimately take the lead on organizing that. Now, I mentioned design workshops, and that's a key idea. This is something that I've been promoting since the early 1980s. These days it's called Agile design. And the key idea is that you surround people with giant whiteboard space. This is the key sort of physical part of the technique. There's a linear relationship between the success of these design workshops and the amount of square meters of whiteboard space. It's that simple. And you don't need to use literal whiteboards. There's these kind of cling sheets. Let's see if I've got some here. Yeah. You can get these cling sheets. They're like plastic. And there's this UK TV show. It's called The Dragon's Den or something like that. And they won an award. They were actually one of the winners of this program. And it's called Magic Whiteboard. And it comes in rolls. It clings to walls. And it works just like a whiteboard. You can erase on it and so forth. And so you can take any walls anywhere, glass, whatever, and roll it out and set up giant whiteboard spaces. And in these giant spaces, then the teams get together and they do Agile modeling. They do sketching in order to come together with common ideas about the vision of the architecture and the design and so forth. Another related technique, and this is especially related to communities of practice, is not only a team-level design workshop, but also a joint design workshop. And this, at the joint design workshop, we'll see members from the design community of practice. So I come from Team Red, and you come from Team Blue, and we come together into a design workshop room, and just like a team-level design workshop, but now at a joint level with representatives from different teams, we come together at the walls and we do Agile modeling and sketching at the level of the overall architecture. We discuss common frameworks, patterns, whatever it is needs to be dealt with. And then we go back to our individual teams and through what I consider to be like a key element of success, which is human infection. Through a human infection model, I leave the joint design workshop, I come back to my team, and then in the team-level design workshops, and then through coding and pair programming and so forth, I communicate the ideas out of the joint design workshop into the team. And since I've discussed the subject of modeling, some people incorrectly think of words like modeling and programming as somehow opposed to each other. But that's just silly. I hope we can move beyond these kinds of false dichotomies and understand that things like programming good, modeling bad are rather naive false dichotomies. And even more important in the context of 1,000 people in 5 different countries, it's quite important to do some modeling together because otherwise it's very difficult to create a shared vision and a shared understanding of the large scale. Now, how do you handle this kind of modeling when you're multi-site, when you've got people in Rochester, New York, and in Los Angeles and London, for example, to take a Xerox product as an example? What I normally recommend is to use multi-site video conferencing meetings with some of these bigger high-end systems, like this Tandberg system, for example. These are quite large and the cameras are quite high fidelity. And so you can, in 2 or 3 different sites, have this camera pointing to a very large whiteboard space at another site and then look through this very large projector and see quite high fidelity what's in the sketch. Another technique that I recommend for multi-site design workshops are what are called diverge and merge cycles. So we're not all, for example, 50 people in 5 sites all at the monitor at the same time. We'll spend a little bit of time together video conferencing, and then we'll diverge, and we'll do things, for example, on separate whiteboards and sketch for a while. And then we'll come back together and merge with techniques like show and tell or other kinds of merging techniques. And these diverging and merging cycles can split the difference between the efficiency of parallelizing separate work with the importance of synchronizing and shared ideas. For very large scale, it's also important to have some communication of the overall architecture as well, which is distinct from a design workshop. A design workshop is something that we do before coding. This is just speculation. A architecture documentation workshop is something we do after development. I normally recommend that you do it just shortly after release. So question, when should you document the architecture? When the code is finished. because the only real architecture is the code, of course. So we develop the system, we release, and then we have a 1 to 2 day workshop that I often facilitate called the Agile Documentation Workshop, where we look back retrospectively at the code and then we document it together. The structure of how we document it, I describe in chapter 39 of one of my old books, basically the N+1 view model combined with technical memos. The environment is a very large space with tons of whiteboards, and the teams will split up, do the N+1 view model separately, do technical memos. Here we see at UBS a group doing an Agile documentation workshop. I also recommend the use of videos so that when we're discussing the motivation and context for the different architectural views, it can be done through a video session in which there's Q&A stuff going on at the same time. So it's all lightweight documentation. Notice also that this technique emphasizes learning rather than just recording, so that the 20 or 40 people in this workshop actually leave the workshop after 2 days with a very deep understanding of the overall architecture, the big picture. So it becomes a real value-adding act as well, not merely a mechanism to document static information. You could say that the output is secondary. The primary result of this is the learning that goes on through the documentation workshop. A couple of other things I've noticed in working large scale over the years is that it's quite common in large systems to have career paths. And the career path is usually out of doing value-adding work into becoming what in Canada we call a PowerPoint architect, if you know what I mean. And so in these large organizations, I often see that there's an endemic problem with PowerPoint architects or architecture astronauts who are so high in outer space you can't even breathe any air with them. And this creates all kinds of dysfunction. And those of you who know me that I've been a passionate programmer since the 1970s, and I'm a keen enthusiast of the idea that you need to be a lifelong programmer. Just like you wouldn't say at a hospital, oh, you know, I've been at the hospital for 10 years and I'm still a surgeon. When am I going to become a hospital administrator? You know, I just never got that mentality. You want to be a surgeon for your whole life. In the same way, you want to be a lifelong master programmer and have a culture of paying people for that and cultivating and promoting a culture of we want master programmers, not PowerPoint architects. We want programmer architects, and we want them to be paid well to do so. I see in really large-scale systems so-called architects who have completely lost touch with they've lost touch with the code, which is, of course, the only real architecture. And then the only thing that they can do is talk to each other. They create PowerPoint diagrams for the other architects, and they're all in this abstract world which has got nothing to do with the reality. It's sad. And I also, you might not have ever thought this, but I've written about this before. I really dislike the phrase architecture. It's completely the wrong paradigm for what we do in software. My partner, my girlfriend, is a real architect, and I can tell you that software development has got nothing to do with real architecture. It's not like the software gods came down in 1968 in Darmstadt at the conference in Germany where this name first popped up. It's not like the name software architect has been deified. It was just an idea, just people grasping for a metaphor. But it turns out to be a bad idea. Architecture, real architecture, is for hard stuff. We build software. It's soft. It's completely different. I like to recommend a culture of gardening. What we're doing is we're gardeners of a continual living thing. We're not building buildings. Other implications in large-scale development, you often have single specialist groups like the systems engineering group, the architecture group, and so on and so forth. All of these need to dissolve, and this is another one of the challenges in moving to large-scale development, is that these special interest groups that often are viewed in positions of prestige, the dissolution of these groups is often a political challenge, but nevertheless one of the things that happens in successful large-scale adoption of Scrum. Sort of a more technical tip, I especially see in large-scale development the notion of branching for customization. Oh, we've got Japan Mobile, and they want a particular specialized version of the telecom system. Let's create a branch for that. That is the path to hell. And if you've been involved in 40 million line systems that are living for 20 or 30 years, and you branch every time for customization, you know exactly what I mean. So stay away from that and focus on configuration for customization. Another thing that we get, this is kind of a reiteration, is broadly the mentality of, in big systems with 1,000 people, oh, that's my code, my subsystem, my custom tool, my framework, not yours. Don't touch it. We want to move away from that to internal open source, as I call it. Now, when you've got 100 teams organized into specialist components, and then you're transitioning, this is a transition tip, and then you're transitioning to cross-component, cross-functional feature teams that work across the entire code stack in an internal open source model, one of the questions that comes up is, well, what if this group touches that component and they don't know that component well and they could screw it up? Now, before I go any further with this tip, I want to note something ironic. Component teams have often been created under the assumption that if you've got 7 programmers that just work on those 3,000 lines of code, they will make that code better than any other organizational design. But here was my experience over the years. I would go and sit down with a programmer in a component team, and they knew that because of my background from my book, Applying UML and Patterns and others, they knew that I cared about clean code and great code. And when we started to look at the code, it'd be very common that the first thing that they would say to me when I started to look at their code in the component team, they would say, Craig, I know it's messy, but we understand it. And the ironic thing about component teams is that it maintains crappy code, ironically. Because you get these 7 people looking at the same 3,000 lines of code for 4 years, and it no longer looks like a big pile of junk. They understand it. They no longer smell the fish, you could say. And this is the ironic thing of component teams, is that it creates systems of bad code. And when you move to cross-component teams, just like with open source systems like Linux and so forth, it creates a forcing function for clean code, because otherwise it wouldn't be sustainable. The system wouldn't be sustainable. Now, back to this transition tip when you're moving from component teams to cross-component teams. You've got all of these crappy little components. Some of them are very delicate and obscure. So what we put in place are component guardians, which are specialists who know that component. And they have a job over, say, 1 or 2 years, ideally working themselves out of that role, to keep their eye on that component while different teams are working on it, because we've no longer got private code. We've now got normal collective code ownership, as in Agile methods. But these people will do things like they'll get a daily diff and an email of anyone who's worked on the code, or if they know that a particular Scrum team is going to be working on their code, they'll go and spend time pair programming with them. They might attend a design workshop. They might do some kind of a review afterwards to keep their eye on it during this delicate transition phase, ideally working themselves a role through refactoring, making the code better, more robust, adding a lot of automated testing, and so forth. Another sort of very concrete tip, in really big systems, a common pattern that I would see is someone trying to figure out the inter-system interfaces early on and get strongly typed definitions of the interfaces. And what I found to be a useful tip is to instead start with weakly typed interfaces across major systems, essentially just a remote function like do, which takes a map of key-value pairs, where the first key-value pair is an operation name, and the other key-value pairs are sets of parameters. And in that way, you can move from more of a, say, a push design model to more of a pull design model, where you organically bottom-up discover what needs to be in these major interfaces. And then after time, as things start to quiet down and these maps essentially start to become stable, then you can transform them into more strongly typed interfaces towards the end. It's a little bit like in landscape architecture, the idea of desire lines, where you don't start by laying down the concrete path path in the park. Rather, you just wait a year and see where people are walking, and then you lay down the concrete paths. I work in embedded systems, so perhaps obvious, but maybe worth saying. Hardware abstraction layers and OS abstraction layers are really valuable. I know a lot of you guys are working in a world like Java and .NET. A lot of my world is C, C++, low-level real-time operating systems, and so forth. And it's quite common in those domains that ultimately you want to shift from, say, VxWorks to a real-time Linux operating system and so forth. And having these abstractions is quite important. Okay, moving from design tips to requirement tips. Now, requirements is a big subject, and so I'm not going to unpack this box very much. But one of the patterns I've noticed over the years in large-scale product development is the question, well, Craig, if we're going to work in a 2-week or a 4-week sprint, and as you probably know in Scrum, the rule of thumb is that an item should be no bigger than a third of a sprint to be done complete. That means this very large requirement, such as an HSDPA call support, needs to be decomposed into much smaller requirements. And a very common problem is that people don't know how to decompose requirements. The only way that they know how to decompose them is into work breakdown structure, into a set of tasks. But there's another approach, traditionally called product breakdown structure, which can be realized with what are called item splitting techniques. These smaller requirements can be split using all of these techniques, splitting by use cases, scenarios of use case, data parts, type specializations, scenario steps, and a lot of other stuff. I don't have time to get into the details, but perhaps you can grasp the implication here is that it's possible to split a requirement with these techniques into smaller customer-centric requirements rather than into smaller tasks. It is possible. I have never seen a requirement in all of my years working that I couldn't break down into something that one team couldn't do in 1/3 of a sprint. I've never seen one. Maybe there is one, but I haven't seen it yet. And so, for example, taking this splitting techniques on something like creating a DHCP server. Here's an overall item at the top described. I want a DHCP server so that I can get a viable IP address. And then first of all, we see splitting by use case, the request use case, the renew use case. And then we see another technique commonly used in splitting called lazy splitting. Instead of eagerly splitting the requirement into all of its children use cases right away, we have a kind of other so that we can do avoiding the waste of overprocessing, to use lean terminology. We can also split by scenarios. So I'll take the request use case, and now I'm splitting it into different scenarios, like the main success scenario and various failure scenarios. And it's quite common to use failure scenarios when you're splitting large requirements. Like, for example, years ago at Nokia Siemens, we had to do HSDPA support, which ultimately would involve hundreds of people for over a year. But we split it down, first of all, into one scenario where the first split child was support for a properly failing HSDPA call. And you can have one team implement support for a failing HSDPA call in 1/3 of a sprint. And then we built up from implementing properly handled failing scenarios until ultimately starting to do success scenarios. Multisite. First of all, a terminology point. By dispersed team, I will mean one team of 7 people that are in different locations. And when we go multi-site, we do not want dispersed teams. They don't scale very well. And there's a lot of research to show that when you've got a dispersed group, you'll actually never socially form a team. Teamness really requires the social interaction that comes from very close contact. Now, in reality, this is essentially an issue of virtualization. I can well imagine that in 100 years in the future with virtual reality technology, I can be in a different part of the world, you can be in here, but using VR technology, it'll be as though two our senses and brain were together, and that will be sufficient to create the social, psychological bonding necessary for real teamness. But today, in 2011, a team really needs to be co-located to be a team, especially if there's time zone issues. But for large-scale multi-site development, you don't need dispersed teams. The question of dispersed teams usually only comes up in small-scale Agile development. If your total product development is 7 people, and 3 of them are in Munich and 3 of them are in Shanghai, well, that's life. But that's not the world that I'm working in. I'm working in a world of 100 or 200 teams, and in that world, it's very normal and absolutely possible to have co-located teams. You've got 30 teams in London, 50 teams in Shanghai, 40 teams in Bangalore, and so on and so forth. Each of those teams is co-located, cross-functional, cross-component. And it's important to understand that the sprint in Scrum is for the product, not for the team and not for the site. So it's quite important that when you move multi-site, everyone needs to be clear that at the end of sprint N, all teams need to have integrated across all sites for a common product that can be released. So the idea is, in large-scale multi-site development, to take a whole feature and send it to a co-located, non-dispersed Scrum team. So you've got 40 teams in Shanghai. Each of those cross-functional complete teams is given complete end-to-end features, and so too with other locations. Obviously, perhaps to state the obvious, there's no single specialist sites. There's nothing like the testing group is in Bangalore and the systems engineering group is in Munich and so forth. All of that evaporates. Also, I normally recommend, if possible, to put a requirement area in one site for the obvious advantages of cohesion. I've noticed over the years, especially with respect to first world versus developing economies, that there's often a power problem where the first world countries that might be the original sites, say like in Munich or Los Angeles or Helsinki, then they get some satellite sites in a developing country like India or the Ukraine or so forth. And these new sites are considered second cousins. And they often feel that they're less important in terms of the power relationship, the interesting things that they can do, and so forth. And it's quite important to try to avoid that and to create a culture where all sites feel that they're equally respected and equally contributing. Obviously, with Scrum, you need continuous integration, and it needs to be around the world. Most of the groups that I see doing this successfully are using Subversion, and I've seen 1,000-person product groups very simply and successfully using Subversion to integrate across the world 5 and 10 sites. So I can tell you from first-hand experience that Subversion easily scales to very large-scale development without problems. And I also see some groups these days starting to use Git and some of these more distributed solutions as well. One thing I noticed as a pattern was that everywhere that I saw clear case used, there were problems. And all of the groups that threw away clear case and went to free open source solutions like Subversion and Git had a much easier time at doing continuous integration and multi-site development. So get rid of it. And I know one executive leader in large-scale Scrum adoption who simply established the rule of thumb: stop using anything from Rational or IBM and things will get better. That's not my personal observation, but... Now, another thing that's quite important for multi-site is that we humans need to see each other to form relationships of trust. And developing big systems ultimately boils down to a human relationship and trust, an emotional bank account between us. I remember years ago when I was working in India, there was a multi-site meeting that was happening over a speakerphone only between a team in India and a group in France. And they had never seen each other. And there was no human connection. There was a lack of rapport, a lack of trust, a lack of respect. We moved to using Skype video combined with a computer projector. You know, just a poor man's video conferencing system. Just a little Mac with a camera in it, a computer projector, and you can set this up on multiple sites, and then for essentially $0, you can have multi-site video conferencing. This is very important. I call it seeing is believing. And this needs to be ubiquitous and cheap. And so if Tandberg would give these away for $5, I'd recommend these. But if everybody can't have one of these in their room, do not use these custom, specialized, expensive systems for what I'm talking about. They need to be ubiquitous, frictionless. So everybody needs to have webcams and projectors everywhere. Reduce the friction of video technology. And I already mentioned this, when you're having multi-site meetings with video technology, use diverge merge cycles. You don't have to be talking together all the time. Nothing more I need to say there, nothing more I need to say there. Now, when you're doing a technique like planning poker, Google Spreadsheet can come to the rescue. If you've got 5 or 6 sites that need at the same time to vote, then what you can do is you can just say, well, Craig, everyone brings up their browser, everyone brings up the same Google Spreadsheet, and we say, well, Craig, you get cell B9, Bus gets cell B11, and so forth. And then when the moderator says, okay, we're going to do a relative estimation point voting for the item, everyone place their vote, then instead of using cards, you can just type into that cell all at the same time. It's completely unnecessary to buy expensive or customized, specialized Agile project management tools for this stuff. I'll also mention, by the way, while I'm thinking about it, avoid any so-called Agile project management tools. These are just old project management tool companies who are trying to put lipstick on a pig so that they can resell their paradigm of command and control, work breakdown structure, and so forth. Just use really simple, free open source tools. Cross-pollination if it's multi-site. It's very important that we go there, they come here. That's important to do that regularly. But at some point, when I come here and you go there, if I'm in London and I go to Shanghai, then my value in Shanghai is partly as a connector back to London. And at some point, my social relationships start to become stale, like after 6 or 12 months. And then my value as a pollinator and connector decreases. So it's quite important to rotate these roles, these pollinators, regularly. Now, in multi-site development, sometimes you get organizational structure where some kind of a manager goes from one site to another site, like a project manager, and acts as a single point of contact or a kind of bottleneck to the people on the other side. Don't do that. What you want instead is what I call matchmakers, where if I go to another site, I'm not a bottleneck or an intermediary for the people on the other side. I'm a connector. Like, you need to be talking to Raj. Now, he plays cricket on Tuesday morning, but here's his Skype ID, and you're going to want to talk to him in the afternoon. That kind of thing. And you're going to want a multi-site communications community of practice as well. You need to consciously focus on making the communication work. Multi-site, usually systems improvement is especially relevant at the site level. Like in the Hangzhou site, we don't have enough whiteboards. And so it's quite normal to have a site-level retrospective. I've noticed that whenever you're multi-site usually implies that some of the sites are in developing countries, Vietnam, China, India, or so forth. And commercial tools always become a friction. I go to these sites and then I say, okay, well, let's use the tool X that they're using in Munich. And they say, we can't use it because we can't afford the license. And that kind of thing happens all the time. So try to stay away from any commercial tools. And similarly, one of the wastes in lean thinking is called the waste of information scatter. And when you're multi-site, it's quite important to avoid old document-centric models like Microsoft Word, SharePoint, and so forth, and move to new Web 2.0 models, just focusing everything in a wiki, for example, so that it makes it much easier multi-site to reduce information scatter. Inspect and adapt at a large scale. What do I want to say? I've talked about joint retrospectives at the beginning of each subsequent sprint. Oh, here's a scaling point I want to make. Oh, by the way, before I wrap up, I hope you notice from this presentation, a lot of keynotes are kind of big vision, soft and fuzzy things, sort of warm and fuzzy talks like my grandmother. But just like my grandmother, they often have no teeth. And and this talk is really just nuts and bolts. I'm not trying to lay out some kind of big vision. I'm just giving concrete tips of how I've made it work. So another tip is, how do you do these big transitions when you've got 1,000 people where for the last 20 years they've worked in a particular organizational design, and now you're making this huge shift? One traditional approach in these large organizations is, okay, we're going to set up a change project, and we'll have a change manager, and the change manager will lead the transformation project. So, a rhetorical question: when have you finished adopting lean thinking? Never. One of the pillars of lean thinking is continuous improvement. When have you finished experimenting with improvement in Scrum? Never. The idea is that every sprint we come up with new change experiments for the next sprint forever. So framing a large-scale transition to something like Scrum as a transformation or a change project with a change manager gives the idea that there's a beginning, a middle, and an end. And we don't want that model. We want the model of, we're going to start adopting lean, agile Scrum. We're going to start the first sprint, and then we're going to repeat until we retire. And so we want a model instead where what does, for example, management do to help support the teams? Instead of leading a change project, which is very much a kind of a top-down paradigm, they move to a model of an impediments backlog and impediments service, where the teams are communicating into a backlog. These are all of the impediments that are in our way to deliver value fast and for the adoption of proper Scrum. And the role of supporting management is to act as servants or servant leaders to remove these impediments that are in the way from the team. Well, I think I'll just wrap up with a short story. A man walks into a bar, goes up to the bartender and says, "Oh, I need a triple shot of whiskey." And the bartender says, "What's wrong?" And the guy says, "Oh, I'm so depressed. I think my wife is going deaf." "Oh, that's too bad," said the bartender. "But don't jump to conclusions. You should actually go home and measure how far away that she can actually hear you." "That's a good idea," says the guy. So he goes home. And he walks into the front door of his house, and he opens the door, and he sees his wife in the living room, and he calls to her, and he says, "Hey, honey, what should we have for dinner?" Nothing. "Hey, honey, what should we have for dinner?" Nothing. He's really close now. "Hey, honey, what should we have for dinner?" And then he hears, "Good Lord, George, for the third time, chicken." Thank you.